All right, we're going to look at problems 2 and 3 from the review. The directions state, given the graph of y equals m of x shown below, sketch the following transformations. So our original graph, y is equal to m of x here, you'll see that that's on our graph over here on the left side. First thing that we're going to need to do here is we're going to need to pull off some critical points. So I'm going to make a little table here. And I'm going to pull some points off here. Now, one thing to notice is that we do have arrows on the ends here. So this graph is going to continue to travel in each direction there. So make sure that when you're doing your transformations that you pay attention to that. So let's see here. I'm going to pull off some points here. So since this is a big straightaway, I'm going to just use the point -3, 2 right there because I know I can extend my line. So for my first point, -3, 2. I've got a point here where it changes directions. That's important to note there. So we're going to use the point -1, 0. We're also going to have a point at 0, 2. It's also shifting directions there. And then we just need one along this straightaway, and then we can extend it on our graph. Let's just use the point, how about 3, 2? All right, so that should make it a little easier because we have a lot of the same y coordinates when we're doing our math on this next part here. So for our problem number 2 here, which is the first transformed function, we're going to look at y is equal to 2 times m of x plus 1. And remember, y is equal to m of x. So when we're trying to create our table to write our rules down, this part of it is right now the same thing as a y. So I'm going to list out a new table here. And let's list our rules here. So when we look inside our parentheses where x is, there's nothing happening to it, which means that we're going to keep the same x values. X is not being shifted left or right. So let's just go ahead and copy the values that we had, -3, -1, 0, and 3. Our y coordinates here, when we look at it here, this is like saying 2 times our y plus 1. So when we write that in here on our table, we're going to do 2 times y plus 1. And remember, this is going to apply to each of the y values in our original table. So starting out here, we're going to take our 2. So we're going to have to multiply this 2 by 2 and add 1, which should give us 5. 2 times 2 is 4, plus 1 is 5. Then we've got our 0, right? 0 times 2 is 0, and then plus 1 is going to give us 1. And we're going to get the same values for this 2 and this 2 because we're using the same rules, so we should end up with 5 and 5 in our table. Now we're going to take it and just plot those points. The first one we have there, looks like there's an extra point on there. Sorry, I'll erase that off. So we've got -3, 5. So we're back 3 up, 1, 2, 3, 4, 5. We have the point -1, 1. We have the point 0, 5. And then we have the point 3, 5. So our graph should make this shape. As it comes down, it's going to hit here. It's going to bounce up, go that way, and then go straight off to the right. Put my arrows on the ends there. And that would be our transformed graph for number 2. For our graph on number 3, okay, we're going to need to probably make another table again. Let's see here. I might need to come up with another color. Let's up with a color that we don't have. Let's try green here. All right, so we're going to take it now, and let's say we've got a table here. And remember, we're going all the way back to the original graph, right? We're not using number 2. We're going all the way back to our original graph right over here. So when we look at the rule at the top, so starting out here, x is inside of here, and we've got x minus 1, which means our graph is going to shift to the right one. So we have to add 1 to each of the x coordinates. For our y values, okay, it looks like we're going to start out with 3, and then we're going to do minus our y, because remember our m of x is like our y value. So when we write this rule out here, this would be like saying either you could do 3 minus our y, or you could think of this as negative y plus 3. Either one of those is correct. Actually, I'm going to move this off to the side because I don't know where my graph is going to be. So we've got negative y plus 3. So you could use either one of those. So starting out here, let's look at our x coordinates there. So the very first x coordinate we have is negative 3. So that negative 3, when we add 1, is going to give us a negative 2. Our negative 1 over here, when we add 1, is going to give us 0. 0 plus 1 is 1, and then our 3 plus 1 is 4. And then we're going to look here. I'm going to treat this rule like it's this one, the negative y plus 3, because I can just take the opposite of the value and then add 3 to it. So our first one here we had was 2, so the opposite of 2 is negative 2, plus 3 is 1. We have a 0, so the opposite of 0 is still 0, and then plus 3 is 3. And these 2's here, since we chose points that had the same y value, should also end up being 1 and 1. So now we're just going to plot those points here and see if it applies the transformations. So we're going to say negative 2, 1 would be right here. We have the point 0, 3. We've got the point 1, 1, and the point 4, 1. So our graph should be making this shape here where it's coming up there, bouncing down, and then going off this direction there. And you can see there that this graph has been flipped from the original graph, right? And it's been moved up 3 units there. So that should be the correct graph. If you have questions about these, make sure you bring them to class. Hopefully this helped you.